Right now, a factory in Japan is manufacturing robots. Amazon's warehouses are run by thousands of robots making millions of decisions, and AI tracing systems are executing billion-dollar trades in milliseconds. But here's the catch. While 99% of companies are investing in AI, only 1% actually know how to use it effectively. And by 2028, that's just 3 years away, 15% of your daily business decisions will be made by AI, not humans. So the question isn't whether AI will run parts of your business, it's how much control you are willing to give it and whether you are ready for what that means. Welcome back. Today, we are diving into one of the most critical concepts shaping the future of AI and robotics: the levels of AI autonomy. Whether you're a business leader evaluating AI investments, a product manager planning autonomous solutions, a robotics enthusiast, or simply curious about how intelligent systems evolve from simple automation to full independence, this video is for you. AI autonomy refers to an AI system's ability to operate and make decisions with minimal or no human intervention. It's essentially the degree of decision making power and independence an AI has in executing tasks. Each level represents a step change in capability, intelligence, and the amount of human oversight that's required. Let's explore each one by one. Level 1, which is the basic automation. This is the starting point. Basic automation driven by fixed rules and scripts. At this stage, an AI system or system follows predetermined instructions to execute simple repetitive tasks with minimal intelligence beyond what's explicitly programmed. There's no learning or adaptation. The system cannot deviate from its rulebook. The robotics example here is an industrial assembly. Think of a robot arm on a factory line that tightens the same bolt over and over, following exact coordinates. It's fast, precise, and tireless. But if the part shifts even slightly, it can't adapt. It's completely dependent on predefined rules. The AI example would be a robotic process automation. In AI applications, level 1 includes technologies like RPA bots that perform routine data entry, invoice processing, or order fulfillment based on set rules. For example, an RPA bot might log into an inventory system every hour, copy data to a spreadsheet, and send confirmation emails. It works tirelessly and error free, but it's completely dependent on predefined rules. The significance for industries like manufacturing, wholesale, and logistics cannot be overstated over here. According to McKinsey, as far back as 2015, about 64% of all manufacturing labor hours were technically automatable with then current technology. This is an enormous scope for basic automation to take over manual work, and many companies have already done it. The benefits of achieving level 1 autonomy are improved speed and consistency, lower error rates on repetitive tasks, freed up human workers for higher value activities, cost reduction through labor efficiency, and 24 by 7 operational capability. But there are risks as well as limitations. There is lack of flexibility. Any change breaks the system. It cannot handle exceptions or edge cases. There is high maintenance burden when process changes. It requires detailed upfront programming, and there is no learning or improvement over time. So, the key takeaway is that level 1 autonomy is now table stakes in many industries. It's a necessary foundation for scaling operations and reducing cost, and it establishes the automation mindset that paves the way for more advanced AI. Let's look at level 2 now, which is the partial autonomy. At level 2, AI systems move beyond the static rules into partial autonomy, incorporating machine learning and adaptive capabilities. The AI can make limited decisions on its own within a narrow scope, but it still requires human guidance or validation for most outputs. Think of this as the driver assistance stage. The system can handle parts of a task using patterns and data, yet a human supervisor must remain in the loop. The robotics example here would be a computer vision quality control, which is primarily used in manufacturing to inspect products on a production line and sort out those that don't match specifications. The AI makes a judgment, pass or fail, based on the learning from thousands of images. However, a human worker often double checks the rejects or tunes the system's parameters. The AI is making decisions, but humans validate and adjust. The AI example over here is a predictive analytics in supply chain, a common level 2 application which is used for demand forecasting. The AI uses machine learning to recognize patterns, seasonal sales trends, historical data, external factors, and then provides recommendations. For instance, it might suggest order 100 units of product X based on predicted demand, but a human procurement officer reviews and gives the actual sign off. The AI is like a co pilot handling analysis while humans make final decisions. Let's look at what are the benefits of achieving level 2 autonomy. This provides enhanced efficiency, that is, tasks completed in seconds instead of hours. There's improved accuracy through data driven insights. It's better decision support for human experts. There is ability to handle large scale operations. There's some adaptive learning that leads to improvement over time, and humans remain in control for quality and ethics. According to McKinsey, companies using AI for data screening and analysis can achieve 10 to 20% productivity improvements in certain workflows. The global AI spending has reached almost $150 billion, with manufacturing and retail among the leading spenders. The risks and challenges. There are model errors and biases if the training data is flawed. Over reliance risk, which is humans might assume AI is always right. It has limited scope, which is AI may fail if it's outside of its training domain, and there is still task specific that cannot be generalized for use cases. It also requires continuous monitoring and validation. So, the key takeaway is that level 2 autonomy represents human AI teaming at its best. The AI serves as a trusted assistant, handling complex calculations and first line decisions, while humans focus on strategic or exceptional cases. Let's move on to level 3, which is the conditional autonomy. Level 3 actually represents a significant leap. Here, the AI systems can make conditional decisions and act independently within well defined circumstances. The system handles end to end execution of tasks under normal conditions without human input, but it knows its limits and will defer to humans when it encounters complexity outside its scope. It's the AI self drives but with a fallback mechanism. The robotics example here would be a autonomous mobile robot in warehouses. These are also called as AMRs, and they can navigate and move goods independently, coordinating with each other to fulfill the orders. Under typical conditions like known layout, clear paths, routine orders, they work without human operators. But if something unexpected occurs, like an obstacle blocking the route or an ambiguous system signal, the robot stops and signals for human assistance. This is why it's called conditional autonomy, which is operating independently until the conditions change. Companies like Amazon and Alibaba use fleets of these robots in fulfillment centers to boost capacity and enable 24 by 7 operations. The AI example here is an advanced chatbot with escalation. So, AI powered customer service chatbots are handling a wide range of common inquiries using natural language processing already. Most customers get their answers from the bot alone, which demonstrates autonomy in those interactions. But if a question fails outside, but if a question falls outside the bot's knowledge or the customer is unsatisfied, the conversation seamlessly escalates to a human agent. The AI knows when to hand off. The benefits of level 3 are significantly reduced need for constant human oversight, 24 by 7 operations with minimal supervision, faster response to known scenarios, greatly improved operational continuity. Humans focus only on exceptions, not routine operations, and scalability, where you supervise multiple processes simultaneously. Whereas the risks and challenges associated with this level are the handoff design is critical as system must know when to ask for help. Poor transitions can lead to silent failures. Defining clear guardrails and fallback mechanisms is complex. Data quality issues can lead to faulty decisions without immediate correction. It requires robust AI governance and monitoring. Trust building is needed to ensure confidence in both performance and escalation. So, the key takeaway is that level 3 autonomy represents a balance where AI handles the known knowns and human handles the unknowns. When implemented well, it can dramatically improve operational continuity and scalability. Let's look at level 4, which is high autonomy. Level 4 is where AI systems become highly autonomous, capable of making independent decisions in complex scenarios with only minimal human oversight. At this stage, the AI can handle most situations on its own. Human intervention is rare and typically only needed for high level supervision or extraordinary circumstances. While highly autonomous level 4 systems remain confined to the environments and task domains they were designed for. Let's look at the robotics example, which is lights out manufacturing. So, consider a lights out manufacturing plant, which is a facility that runs 24 by 7 with almost no on site human workers. AI driven machines and robots coordinate production, they handle materials, perform quality checks, and even adjust to routine variability on their own. Well, this isn't science fiction. Real examples exist in the form of FANUC in Japan, which has operated a lights out factory since 2001, using robots to manufacture equipments with zero human intervention on the shop floor. The Philips factory in Netherlands runs with 128 robots and just 9 human workers overseeing the quality. These are real instances of level 4 autonomy where humans set goals and parameters and AI powered machines handle almost everything else. The AI example over here would be autonomous supply chain planning. Level 4 supply chain AI platforms use deep learning to continually optimize procurement, production scheduling, and distribution. Such a system could receive sales forecast, autonomously decide production quantities for each factory, allocate inventory across warehouses, select transportation nodes, all while respecting constraints like cost and capacity. Human supply chain planners would only step in to tweak the strategy or handle severe disruptions. The AI otherwise manages the entire flow. So, what are the benefits of level 4? Well, massive efficiency gains, impossible with humans in every loop. This continuous operation and real time reaction to data. It's higher precision and safety as AI doesn't get tired. There is dramatic scalability to manage far larger operations with the same team. There is flexibility as AI can optimize in ways humans might not spot. and there is better resource utilization and significant cost savings. The AI Lighthouses initiative by the World Economic Forum and McKinsey showcases factories extensively deploying AI and automation. They report not just productivity improvements but also more flexible production that can switch product lines with minimal incremental cost. But there are risks and challenges. There is high dependence as it's a single point of failure if AI malfunctions. Mistakes can propagate widely even before humans notice. Black box problem, and so it's difficult to diagnose the unexpected behaviors. Governance and accountability challenges. There are security risks as highly autonomous systems are attractive cyber targets. The quality is heavily tied to AI's training, and any flaw has large repercussions. Organizational impact could happen with significant job role reshaping when it's required. There are cultural adjustments needed from doers to AI supervisors. Gartner emphasizes that managing the risk of autonomous AI agents requires strict guardrails, oversight tools, and robust monitoring. Data governance is paramount since AI is largely on its own. So, our key takeaway here is that level 4 autonomy offers a leap in efficiency and capability, but it demands rigorous risk management, strong governance, and change management to implement successfully. And last but not the least is level 5, which is full autonomy. This is also called the pinnacle of autonomy. It is where AI systems operate completely independently of human intervention. A level 5 AI can handle any task, decision, or scenario within its defined domain just as a human expert could, or sometimes even better. There are no hands off to humans in daily operation. Humans simply set goals or high level direction, and the AI figures out the rest. An important distinction to note is this is still domain specific autonomy, not artificial general intelligence. An AI might achieve level 5 autonomy in supply chain management, for instance, but that doesn't mean it can write poetry or design buildings. The example for robotics would be a fully autonomous factory. The ultimate goal in manufacturing is a dark factory, that is, an end to end lights out operation where an AI system not only runs production machinery but it also makes higher order decision. What it really does is scheduling production runs based on orders, adjusting plans when supply is disrupted, performing predictive maintenance on itself, optimizing energy usage, and all without human approval at each step. While even the most advanced factories today keep humans for oversight, the goal is to eventually remove the need for even on site human decision making entirely. The AI example over here is a fully autonomous supply chain, which envisions a fully autonomous chain that can monitor global demand and supply in real time. It automatically sources from optimal suppliers. It balances inventory across networks, routes products using dynamic logistics, uses autonomous vehicles and drones for delivery, and self optimizes continuously. Some leading companies are experimenting with elements of this vision, but full implementation still remains aspirational. As we all might know, the benefits include there is unprecedented scale and scope, which is beyond any human team's capability, instant response to changes and real time adaptation, potential for continuous self improvement through learning. It's ultra lean operations with near zero manual labor, human talent redirected to creative, strategic work. New business models are enabled for 24 by 7 autonomous services and the competitive superpower for early adopters. And last but not the least, there is personalization and optimization, which were previously impossible at scale. If this is harnessed safely, level 5 autonomy could allow companies to accomplish things currently which are impossible due to human resource limits. But there are several critical risks and responsibilities in this level of autonomy. There's absolute trust requirement as there is no safety net if AI fails. Any system flaw can have catastrophic consequences. There are profound ethical implications as AI is making decisions that's affecting stakeholders. There are accountability challenges. Who's responsible for AI's actions? There is maximum security risk, which is attractive target for cyber attacks. There is loss of human expertise over here. Societal impact, as there's going to be a significant workforce displacement, and this requires world class AI governance and external oversight. Well, Gartner also warns of risks like agentic AI driven cyber attacks if the guardrails aren't in place, and companies must establish clear accountability frameworks, continuous auditing, and probably keep humans ultimately accountable for the AI's actions. The key takeaway is that level 5 autonomy is the vision of AI driven business offering transformational benefits but requiring world class governance, ethics frameworks, and careful implementation. Most organizations treat it as an ultimate goal to work as both technology and trust evolve. So, what this means for all of us is specifically for business leaders, assess which processes could benefit from higher autonomy. Start with level 1 or 2 for quick wins and foundation building. Invest in AI governance infrastructure early and plan for workforce transition and rescaling. For product managers, you need to understand the autonomy requirements for your product, design appropriate human oversight mechanisms, build trust through transparency and reliability, and consider hybrid approaches for different features. Well, we journeyed through the 5 levels of AI autonomy from basic rule following automation to fully independent intelligent systems. Each level represents a step change in capability, bringing new opportunities and new responsibilities. The key insights for us to remember here are autonomy is a spectrum, not a binary. So choose the right level of each application. Number two, higher autonomy also means higher benefits and higher risks. Governance, ethics, and trust are critical at every level. The future is collaborative, and humans and AI will be working together. The AI and robotics technology is advancing rapidly, so now is the time to prepare. And with that, we come to the end of this presentation.